Okay, now that we've established what it means to define a relationship between two sets of numbers, let's talk about what it takes for that relationship to be defined as a function. We're going to talk about what that actually even means. So let's take a look at this definition and these examples. Now, I will say that I have two examples here. One is a function and one is not a function. We're going to look at the definition that's written here and we're going to decide which one is which. So here's our definition of a function. A function is a relation where every input has only one output. For some reason, we have a little bit of a, let me zoom back to, there we go, now you can read the whole thing. So a relation where every input has only one output. Now let's see if we can figure out what that means looking at the blue and the red example. We have in the first example, it's a bit repetitive in the output here, right? Every y value is 2. X still has 1, 2, 3, 4, 5. So we said X is the input, right? Input, or the domain. And the Y is the output, or the range. So input, we have 1, 2, 3, 4, 5 are our possible input numbers, and no matter what we put in, we get 2 as our answer, as our output. So the question is that okay? Is the repetitive nature of that okay? Can it be defined as a function or not? Second example in the red, we have input of 1, 2, 3, 3, and 4. So we've got another case of repetitiveness here, which we're going to think about. And our output, or our range, is 2, 2, 2, 5, and 2. So specifically, 1 will give us 2, 2 will give us 2, 3 will sometimes give us 2 and sometimes give us 5. So that's a little weird, right? The idea that if I plug in 3, I might get 2 or I might get 5, and there's nothing to tell us when I get 2 and when I get 5. And then we have 4 that has an input of 4, an output of 2. So, which example is a function? Let's go back to our definition. A function is a relation where every input has only one output. So we ask ourselves in the blue example, does every input have only one output? The answer is yes. Now don't be confused by the fact that the output for each of these numbers it just happens to be the same. But what I'm really concerned with is the fact that if I input 1, there is no doubt in my mind the answer is always 2. The output is always 2. If I input 2, my output is always going to be 2. I always know if I give an input, I know exactly what my output is going to be. My problem, so I'm actually going to say, yes, this is a function, because every input has one output. The problem happens in situations like this down here at the bottom. That was like the messiest parentheses ever. Let's try that again. So looking at this situation, I have a problem here. 3 gives me 2 sometimes, and 3 gives me 5 sometimes. Let's think about a real-life example where this would be a bad thing. Imagine if you had a button on your computer that when you pressed it, sometimes it turned the computer on, and sometimes it made it blow up. Would that be a reliable situation? Which doesn't take much thinking to say that would be a very bad situation. We don't really want like a guessing game button that sometimes turns it on and sometimes might completely destroy the whole thing. That's a problem. That's kind of like our situation over here. Sometimes 3 is going to give us 2, and sometimes it's going to give us 5. We have absolutely no idea when it's going to give us what number, which creates a very unpredictable scenario. So that's not a function. If we have that uncertainty, it is not a function. On the other hand, thinking about the repetitive nature of the first example where every input gives me 2, and we ask, is that okay that we have the output of 2 happening multiple times? Well, using the same idea of a computer button that turns it on, turns the machine on, think, would it be okay if I had 2 buttons who both had the goal of turning the computer on? Would that be a problem? Well, no, it wouldn't be a problem. I mean, it may be unnecessary. Like, why do I need two different buttons that accomplish the same thing? But is it unpredictable? No, that's not unpredictable. So if this button says on, the input of button 1 has an output of on, and the input of button 2 has an output of on, it's still a function. It's still predictable. We don't have that sense of uncertainty. And that's really what we have in our blue example. The idea that it's almost like we have the 1 button, the 2 button, the 3 button, the 4 button, the 5 button, all happen to accomplish the same thing. They all give us a result of 2. Is that unpredictable? No, that's actually almost too predictable. Everything gives us 2. So if we have that sense of predictability where the input always is going to give us a predictable output, then we call it a function. If the input is unpredictable and gives us different outputs, then we just call it a relation. So it's not a problem. It's not like, oh, this is like something horrible in the world of math. It just means that we can't define it as a function because we're much stricter about how we define functions. So a lot of talking there, a lot of defining, not a lot of math work. However, as we work on some problems in class, I'm probably going to ask you to identify for me what it means for something to be a function or not a function. Now, this is kind of like part 1 along this topic. This part 2 is I'm going to show you how do we define what a function is when we have a graph. Because remember, we talked about graphs a moment ago. How do we know if we have a graph of a function or a graph of a relationship, whether it's a function or not?